numbers. This is the review for absolute value and graphing of complex numbers. Okay, first off, let's take a look at all these. Remember that absolute value is your distance from 0. When we graph, maybe if it'll give me a pen here, when we graph, this is our real axis and this is our imaginary axis. So the point 3, 1, 2, 3, negative 3i, 1, 2, 3, is right here. Its distance from 0 is this line. I can create a triangle, a right triangle, with a side that's 3 and a side that's negative 3. Using what you know about the Pythagorean theorem, I know that this distance is equal to, d squared will be equal to 3 squared plus negative 3 squared. D squared is equal to 18, that's 9, plus 9 is 18. D is equal to 3 square root of 2. Because remember that 18, that's the same thing as 9 times 2. So when I take the square root. So this absolute value over here is 3 root 2. Now, I'm not going to graph all of these, but this is the idea. I'm going to put a little number 1 over here so you can kind of refer to it. For all of these, your absolute value of a plus bi is equal to the square root of a squared plus b squared. You're simply using your knowledge of right triangles. So, without further ado, let's try these. This is going to be equal to the square root of 4 squared plus 6 squared. This is the square root of 16 plus 36, which is equal to the square root of 52. 52 is divisible by 4, so which is 13, which means you've got the square root of 4 times 13, so it's 2 square root of 13 when it's in simplest radical form. Okay, getting the idea here? Then we're looking at, I'm going to do these. Actually, let's see if I can erase this one. So we've got that one. You can pause the video and look at it if you want. Otherwise, I need a little more space. Okay, this is equal to the square root of 4 squared plus 4 squared is equal to the square root, that's 16 plus 16 is 32. This is equal to the square root of 16 times 2, or 4 square root of 2. Next up, we have the square root of 4 squared plus 7 squared. This is equal to the square root of 28 plus 49, which is equal to the square root of 77. 77 is just 7 and 11, so you can't do anything else. Whoops, did I screw that up? Oh, I did. I'm looking ahead. I don't even know what I'm thinking. Silly me. Trying to do too many things at once. 16 plus 49. 16 plus 49 is just 65. And 65 is 5 times 13, so it still is not, you can't simplify it anymore. Here we have the square root of 3 squared plus 4 squared is equal to the square root of 9 plus 16. That's the square root of 25, which is 5. Absolute value, distance, absolute value, distance from 0 which in this case is the origin. Okay? All right. I'm going to erase some of this stuff over here. You should have that copied down by now. And give you a chance to take a look at these. If you haven't already tried the even ones, pause the video and try them. Look at what you're doing over here. Start the video up again and check your answers. Are you back? Okay, let's make all of these guys go away. Then, I do want to comment about number 8. Number 8 is equal to the square root of 10 squared plus 1 squared. Remember that this is, whoops, okay, maybe. This is 1i, not just I, it's 1i. So it's square root of 10 squared plus 1 squared is the square root of 101. The negatives don't really matter because remember a negative when you square it becomes a positive, so we're all good there. If you have any questions on 2, 4, 6, or 10, bring them in. Now, graphing. Here I've just shown the answers. I'm going to do a quick go through of these, but it's really hard with the pen to graph, so I already put the points in here. 5 minus I. Real is the x-axis, imaginary is the y-axis. So if I go out 5 on the real, minus I is down 1 on the imaginary. 5 minus 3i, 5 on the real, down 3 on the right. 1 minus 2i, 1 to the right, 2 down. Real, imaginary. Remember that a plus bi, this is your real term, plus your imaginary term. And you're going to graph the a and the b. Negative 2 plus 5i, I go left 2, up 5. 2 minus I, to the right 2, down 1. That's it for graphing. Finally, we're identifying each complex number. If I give you the graph and the point, you have to tell me what it is. Remember that on this one, the real axis, this is your A. The imaginary is your B. And you're going to give me your answers, A plus BI. So, for here, I've got 1, 2, negative 2 on the real axis, then 1, 2, 3, 4 on the imaginary. So this should be negative 2 plus 4i. Over here, we went 2 to the right. So I have 2 on the real axis, 1, 2, 3 on the imaginary. So this should be 2 plus 3i. Down here, 1, 2, 3, 4 on the real, 1, 2, 3, 4 on the imaginary. 4 minus 4i. 1 on the real, negative 3 on the imaginary. 1 minus 3i. 4 on the real, 1, 2, 3 on the imaginary. 4 plus 3i. That's it for graphing, identifying, and getting the absolute value. All right, great job. Good luck on that test.